Hello everybody, welcome to our next unit. This unit is all about circles. You are going to learn more about circles than you ever knew was a thing, right? So first thing we're going to start out with in our circle unit is a bunch of vocabulary, because in order to learn stuff about circles, we have to be able to talk about circles. Some of these words, I'm sure, as you can see on the screen, you've seen before, and some of them will be new to you. Do yourself a favor, and as we're going through here, write down these definitions and examples so that you can refer back to that if you need to when you're working on problems, because there are a lot of vocabulary words. So we're going to write definitions, and then we're going to draw a little picture to show us what each thing is. Okay, so the first thing is we have to define what a circle is, right? Now, you've probably known what a circle is since you were watching Sesame Street, right? It's the Sesame Street word, and we have to define it in terms of geometry. So for circles, I start out with the definition that we like, that it's just this perfectly round shape, right? When my daughter was a baby, she used to say, circle like a ball, which isn't technically true because balls are 3D, so they're spheres, but she was 2, so it's fine. Right? But they're perfectly round. They're not oblong at all. They're not like ovals. And they're very specific when we say a circle. So the geometry definition has to be a little more specific than that. In geometry, we talk about a circle having a center. So it's this point right in the middle of the circle. And technically, the way we talk about a circle is we say that it's a shape where every single point on the circle, so if I put any point on this line at all, it will be the same exact distance from the center. So in other words, if I can go from the center to any point out on the edge, and it will be the same distance. That's exactly what a circle is. I can't do that with any other shape. If you have something that's a long oval shape and you put a dot in the middle, if I go from here, it's going to be a short distance, but if I go to there, it's going to be a long distance. Even in something like a square, I can go out to the edges like this and have it be the same distance, but if I go out to the corners, it's a longer distance. A circle is the only shape where I can go to the center and then go out to any point on the edge of the circle of the shape and have it be the same exact distance. It's a very special shape. Okay, so since it's a special shape, that's a special distance. We give that special distance a name, and the name of that distance is our friend radius. Okay. So the radius is the distance from the center of a circle to any point on the circle. And again, you've seen this word before, 100%. So here's the center of the circle, and here's any point, I don't even care, on the edge of the circle. This distance right here, it's a segment, right? It has a starting point and an end point, and it is the radius, and we label it R. R is for radius. Okay, so again, you've seen that before. Now, you've probably also seen the word diameter here, right? But we're going to talk about this other word first. This word is chord, right? It's spelled in the same way that you would spell, you would spell like any other chord like you use to plug something in, okay? A chord is also a segment in a circle, but it connects any 2 points on the circle. So for a chord, the center of the circle isn't necessarily involved, right? So if I have a chord, I can draw a line that connects this point and this point. That's a chord. But I could draw any number of chords. I could draw a gazillion, million, trillion chords in this circle. I could draw another one that comes up like that at an angle. A chord is very generic. It's a very general term for just any line that happens to go touch 2 points on a circle. Okay, so I could go from any point on the circle to any other point on the circle, draw a line, and that's considered a chord. It's not very exciting. So our friend diameter, though you probably never talked about it this way before, is technically a chord. It connects 2 points on a circle, but it also just happens to go through the center, and that's the key to a diameter, right? So it connects 2 points on the circle, and it happens to go exactly through the center of the circle. We can also say that a diameter is exactly twice as long as a radius, right? Because a radius goes from the center of the circle out to Radius goes from the center out to the circle, right? That's a radius. And if you go from the center but go out the other way, that's a radius. So if you put these two radii together, that distance right there is the diameter. So you may have learned a long time ago that a diameter is 2 times the radius. So if I say to you that a circle has a radius of 10, then we know the diameter of that circle must be 20. It's always 2 times. It's diameter. All right, so let's take a minute and let's try to look at a diagram and identify these parts. Circle, radius, chord, and diameter before we add a few more vocabulary words to our list. Okay, so first things first, we need to talk about naming circles. So when you look at this diagram, there's a lot going on in this diagram, right? But I see 2 circles. I see this one on the left that's bigger. I see the one on the right that's a little smaller. We name circles based on their center. Okay? So this smaller circle right here has a point right in the middle. This point right here, that is the center of this circle. There are a bunch of points right here that are the same distance from that point right there. So we would call that circle X. There's this bigger circle over here. If we want to name it, all we have to do is find its center. In this case, the center is this point P, so we would call that circle P. When we name a radius, we have to name it like a segment. So you may remember back in the beginning of the year when we talked about the different kind of things that you have in geometry, right? You've got like lines and segments and rays and stuff like that. A segment is written naming 2 points, which are just the endpoints, right? So if I want to name a radius, let's go over here to this circle. Let's go to circle X. Okay? A radius is going to be any line that takes me from the center out to the edge of the circle. So for example, X, Y, that's a radius because it goes from the center out to the edge. Now, in this diagram, I see a couple other radius, or radii is plural, as well, right? XU is a nice radius. Takes me from the center out to the edge. And also XR is a radius. So just for that triangle, I can't get out of the last unit. Just for this circle right here, there's 3 different radii. So let's write that word down because it's a funny word. Radius is just one. If there's more than one, we call them a radii, and it has 2 I's in it. It's funky, isn't it? Okay, so there's 3 radii there. All right, so we can do the same thing over here for circle P. Circle P, I can see 3 lines that come out of center at P and go to the edge. There's PQ, there's PM, and there's PN. So you could label any number of radii in a circle. In fact, if I wanted to, I could go PR. It wasn't drawn in for us, but it's a radius, just like any other one. Okay, so let's see what chords we have labeled. I'm going to clean up my diagram a little bit here. Oh, chords. Okay, so for a chord, I'm just looking for a line that just happens to willy-nilly connect any other 2 points on the circle. Okay, so let's see. If I start here at point U, point U. Let's follow this line and see where it takes us. U, Y. Look, that's a chord. U, Y. Okay. There's no other lines that leave U other than UX, and we know that's a radius. Right? How about Y? So YU is a chord. How about YW? Connects 2 points. YW. All right. There's no other lines that leave W. Now, this is interesting. R. R cuts across and goes to Y. So technically that's a chord, right? It connects 2 points on the circle, but I would also consider RY a diameter. So it's not that it's not a chord. The definition for a chord is very loose. It just has to touch 2 points on the circle, right? Diameter is much more special. Right? So yeah, it's a chord, but it also happens to be a diameter. All right, so let's go over to our other circle and see what we can find. If there's any chords over here. So again, let's go to point M. Let's start there. Okay. This segment, MP, that's not a chord. It takes me from the edge back to the center. That's a radius. MN, oh, that's a chord. See, MN. Okay, so there's no more around M. Let's go up here to R. RQ. That's a chord. Takes me from one point on the circle to another point on the circle. So I can use RQ. How about some other points? Let's see, Q back to P, that's a radius. N back to P, that's a radius. And then there's these lines out here, which they're not even inside the circle, so that's not going to help me right now. Oh, I forgot. I was going to say, what about a diameter? Well, look here. We've got Q going all the way across to N. So technically I can list that as a chord, but it's also the diameter of the circle. It goes all the way across. Right? So if PQ, see this? PQ is a radius, and also PN. Look, PQ and PN come together to be that whole diameter. Okay, so I would like you to take a minute, take a look at this diagram, and use this new diagram to answer the questions. All right, so first things first, we want to know what the center of this circle is, right? So if I want to know the center of the circle, I go all the way around the outside and look for the point that's right smack dab in the middle, and that would be, that would be point E, right? Whoa, point E is right in the center of my circle. Okay, so from my center, if I'm looking for a radius, I should be able to go from the center. It's got to come to the center if it's a radius, and out. So EH is a radius, EB is a radius, EC is a radius, and EF is a radius. All four of those lines are radii. Okay, any line that starts at the center and heads out to the edge is going to be a radius. Okay, now, as far as a diameter, basically what I need are two radius that come together to build a bridge all the way across the circle, right? So if you look here, if I go from B to E and then to F, that gets me all the way across, but it's a bend. We don't want that, right? But if I use these other two, if I go from C to E to H, that gets me all the way across in one straight line. So this right here, CH, that's my diameter. Now, as far as chords go, I'm just looking for lines that touch 2 points on the circle, right? They're going to kind of cut through the circle, but they're not special. It's not a radius. It's not a diameter, right? So in this case, I've got two of those. I have GF that touches those 2 points and cuts through. And then over here, even though it extends, just this little segment right here, BC, that is a little chord. Okay? So this diagram has two chords. Okay? Notice this line right here, it didn't cut through the circle. A chord has to come through and touch 2 points on the circle. This line doesn't do that. It's not that this line isn't special. It is. It's just not a chord. Okay? All right. So let's talk about a couple more vocabulary words here. These I'm thinking you have not heard of or seen yet. These are fancy words. All right. So a secant. Okay. We kind of already know what a secant is. This is such a little detail that it's like, you know what, math? We know that a chord touches 2 points on a circle, right? It's a segment that goes from one side of the circle to another point on the circle. A secant is the same exact stinking thing. The only difference is it's a line, not a segment. In other words, it keeps going. Okay, so it's literally the only difference is a chord has endpoints, a secant doesn't, right? So a secant line, see how this has arrows on the end? That's the only thing that makes it a secant instead of a chord. So notation, 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 right? If I have points, if this is point A and this is point B, right? If I write AB like that, that's a chord. If I write AB like this with the arrows, that's a line, that would be considered a secant. It's silly, but it's true. Okay? We talk about these in calculus all the time. They come up all the time. We say a secant line, and then we say a tangent line. I never just say a secant. I always say secant line, tangent line, and it helps me to remember that it isn't just a segment. It isn't just a piece. It's a whole big line. Now, a tangent, like I just said, is also a line, so it keeps going forever and ever, but a tangent line is special in a different way. So a tangent line is a line that cuts through the circle, but it only touches one single point on the circle. That looks funny. This is what a tangent line looks like. I always used to tell my kids in calculus that a tangent line comes across and it just I thought I put a little point of tangency on it. No, I didn't. Okay, a tangent line comes by and it just kisses the circle and runs away again, right? There's tangent lines on all kinds of graphs, right? And they become really important later in math. And right now in geometry, we're only going to talk about them with respect to circles. But a tangent line literally just comes by and goes smooch, kisses the circle and keeps running, okay? So that point right here where the tangent line comes by and smooches the circle, we call that the point of tangency. In other words, it's the point where the tangent line touches. That's all. Okay? So if you have a tangent line, it's going to look different than a secant because it doesn't cut through. It just comes right to the edge of that circle, just barely kisses it and keeps on trucking. Okay? The point where it just barely kisses it is called the point of tangency. It's very fancy. It's very fancy. Okay, so let's take a look at the picture, the same picture from before, and see if we can find a few of these things. Okay, a secant. Okay, now, where there used to be a chord, I need to see if there's a line. So for example, over here, before when we were looking for chords, we said that UY was a chord, right? Well, guess what? I could also, instead of just looking at segment UI, I could say, look, this extends in both directions. There's arrows on both ends. So since it's a line that cuts through two parts, I can say UY, and I have to be careful with my notation. The line, that's a secant line. Now, over here on this one, I don't see lines on any of these, right? I can't say MN secant line because it doesn't keep going, right? See how this one has the lines, the arrows on either end, it keeps going. This one doesn't do that. Neither does QR. So I can't call them secant lines because they're not lines, they're segments. It's picky, but it's true. Okay, now, as far as a tangent line goes, I need one that only just comes by and keeps going. There's only one other line in this diagram. Look at this line right here. It goes SRT, and look at this. At this point R right here, it's a one specific point where the two circles touch and this line right through. So that line right there, you could call it line RT, you could call it line RS, you could call it line ST, whatever you want to call it. That's a tangent line. It's a tangent line on this circle, and it's a tangent line to this circle. Its point of tangency is the point where it touches the circle. So R is considered a point of tangency. Okay? All right. So now it's your turn. All right. Find me some secants and some tangents and some points of tangency. Okie doke. All right. First things first. Secant. Now, I just want to say that I made this diagram. And on the program that I made the diagram, I can't put arrows on the ends of my lines. So, should have, before I sent you off, done this. But I didn't. All right, so if I'm looking for a secant, I'm looking for a line that cuts through, right? So here, I could say that line AD, considering that there's arrows on it now, right? I could also name it AB, I could name it AC. I could name it BC or BD because there's all these points, right? This line is a secant line because it cuts through 2 points. Okay. Now, tangent line, I'm looking for one that doesn't ever go inside the circle, right? A tangent line comes, kisses the edge, and then keeps going. It doesn't dip inside the circle. And there's only one line like that, and that's this one right here. So line KI, you could call it, line KJ, line JI. That's a tangent line. And its point of tangency is going to be the very point that it touches the circle, or J. That's my point of tangency. Okay. So we have much more to do with circles, much more vocabulary to talk about with circles, but for now, I think that's quite enough. You have, what, 7 new words filled out? Hopefully they weren't all new. Okay. Any questions that you have, pop them in the end of the video, and we will talk more soon.